start, go. So, example of a sequences. Well, first we're going to write down lots of definitions. The beginning of the chapter will have lots of definitions, but in this case they're pretty fun, you will see. We will denote A, that's very fast, A1, A2, A3, with the commas between them as a sequence. A1, A2, A3, keep going, dot, 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 3 dots usually, A sub n. That is a sequence. As you can see, sequence is a list. That's important because then we're going to have a sum of that stuff later. This is a list. The list has the nth term, usually A sub n, A sub n. So definitions. Number 1, number 2. A sub n is the nth th term. Nth term, that's important. Usually nth term is a representative of the sequence, and we ask you to find it for that reason, to see the representation. Different notations you will see in different books around the world. We all teach sequence and series in all calculus classes around the world. It's very classic material. So you are struggling right now, people in France struggling with the same material, and in Ukraine and everyone else. So those are braces, or curly parentheses. You can check the definition. I call them braces because someone told me to call it braces. A sub 1, comma, A sub 2, comma, go, go, go. A sub n. This is one of the notations. It's exactly the same thing I just showed you, but it was different notation. That is a sequence. Sometimes people just know the representative, the nth term, and they just put the nth term there. And then they say, computer scientists will like this, n is running from 1. Well, now you have to actually change the n to n. So let me change this idea to like so. You're not supposed to use the same variable, so nth term maybe will be as, oh, let's do it, a to the k, like this. A1, A2, A3, A4, blah, 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 up until A sub k, and then n is running from 1 to k. N in this case is a dummy variable. It's an official term. Computer scientists see it a lot when they code. It's I, J, K, N. Those are reserved, nice counters. Let's call it a dummy variable or a counter. It counts. It's a counter. So it counts sometimes from 0, sometimes from -7, -7, -6, -5, -4. And so on, and then keep increasing. One more notation you will see in the books is just writing it down like so. A sub n, and then they say where or with. Where n is running from 1, comma, k. That is a notation. And the new notation I saw in America only was this one, and I kind of liked it. 1 is A, comma, K, and there's a bar connecting them. That is the same thing. So lots of different notations, pretty fun. You should know that sequences can be infinite. If the sequence is infinite, it will look like so. A1, blah, 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 A sub n, that's the nth term, blah, 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 forever. If it doesn't have the end, that means we assume it's infinite. And the notation for this will be the nth term. N is from 1 to infinity, like so. And we will be working mostly with infinite series and infinite sequences. It's a list. Basically, it's a list. And list can be anything you want. I usually give example of cities. So list of cities will be braces, and then you have Salt Lake City. I like that. Let's put Tempe. Why not? What else do you want to put? Something I can write down without a mistake. LA. New York is easy to write down. Let's do that. New York City. And now this is the list of 4 terms. But it can be well, it can be infinite, so it can be n terms, and then you keep listing how many cities you want to have. List, so it makes sense. Now let's do something interesting. That's going to be your first homework. Your first homework will be like a puzzle. They will ask you to figure out something, and you will stuck, and you will either like it or you will not like it. Formula notation. Notation. The beginning of this chapter is a true puzzle. So if you do puzzles for fun, you will actually enjoy this beginning of the chapter. 8.1 is a true puzzle there. So some of people are actually really enjoying it because there is not so much math as it's actually just logical puzzle. A, if I give you this notation, n over n plus 1, braces represent that it is a sequence. N is running to what? From 1 to infinity. What does this mean? And it's the most important part here is to explain to you how to write down sequences in series, which is 8.2. So, n is 1. N is a dummy variable. N is a counter. It starts counting from 1. Let's plug it in. N is 1 at first. Since it's a sequence, I will open the braces and I'll plug n into the formula. The formula says it's n over n plus 1, so it's going to be 1 over 1 plus 1, comma. And we can simplify later. What is the second term? People over there at the very corner at the end? Who can you tell me a second term? When n is 2, what is going to be? Come on, people over there. Over there. The handsome student. I wonder who is. I wonder now, like people like, is she talking about me? Like, no. Aha, good job. 2 over 2 plus. I will get fired for this. It's like I should not say that. But it's kind of funny, right? The cool person in the room, like who's gonna answer, right? Anyway, so. And so on. Do I need to write down the third one? I don't want too much same stuff. Dot, dot, dot. And then we're actually writing down the nth term. Nth term, when you plug it in, but it already was there, so it's n over n plus 1. That's my nth term. Because it's infinity, we do not stop here. We're actually gonna go comma, dot, dot, dot. That means it's infinite, closing the braces. That is the formal notation for the sequence. Let's simplify it. Equal sign, equal sign. What is the first term? Everyone can tell me. 1 over 2. The second one? 2 or 3. Can you guess the third one? 3 over 4. And the other one? 4 or 5. So you see the pattern now. And the pattern can be described as n over n plus 1. Now you see where it's coming from. And the numerator is 1 unit behind the denominator, or denominator is 1 unit ahead than the numerator. That's it. That is the idea here. What do you think about this? If in the homework they ask you, can you tell me what is the nth term? You do like so. It's written like so. A sub n is n over n plus 1. That is the nth term. The nth term. Oops, don't jump. So you will see it, they will ask you that. Let's do something more complicated, more interesting. Oh, the nth term is also sometimes indicated like so. People actually see it visually. When you see lots of sequences in series, you see the nth term visually, it's there. B. How about this one? B. It's gonna be more interesting, minus 1 to the n. Boom, where did minus 1 came from? Well, why not? N plus 1, so now the numerator is 1 unit ahead. But then denominator is 3 to the n. So divide by 3 to the n. Erase your small braces and make them bigger. That is the sequence now. Let's see. N is from, and you see it can be actually from any number I choose. I can choose -7, which is not common. Usually people try to avoid using negative numbers. And if they are, they're making a shift and shifting it to 0 or 1. And this time I will start from 0. So what people do not agree is when to start, from 0 or from 1. You'll see different examples. So pay attention on the very first term. The first term starts the sequence. N equals 0. Plugging 0. Let me ask people in the audience. People at the end of the middle row. What do you think over there? Anyone want to say the 0 term? Read me not the final answer, but actually how to write it down. When n is 0, what do you think is that? People over there, come on. -1 to the 0, amazing. 0 plus 1, amazing. 3 to the 0, thank you. Do you all agree? Correct, not correct? Should I add something to this? Plugging 0. That's literally what the idea of the counter is to plug 0. Thank you so much. N equals 1. Let me hurry up. Did anyone want to tell me? Or should I just write up? People in the middle of this row and to the right. With lots of laptops. Probably doing computer science homework. Come on. Who is smiling? That's when you should... Yeah, go. Yes. Whoever is smiling got in trouble. So plug 1 gives you what? Yes. 1 plus 1, thank you. 3 to the power 1, exactly. Thank you so much. I don't like how shrinked it is, but it's okay. To the 1. Comma, dot, dot, dot. We know it's keep going. Write down the nth term, -1 to the n. Okay, you see you have to have enough space for this one. N plus 1 over 3 to the n, comma, dot, 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 and there is no end. If there is the end, they would tell us it's from 0 to 5 or from 0 to 100. Then it will be a cut of the sequence. Infinite sequence will have finite number of terms. But this one is infinite, so I don't have any end. Looks like this. Let's quickly simplify. Let's quickly simplify and see the pattern. What is the first term? 1. Let's check. -1 to the 0 is 1. 0 plus 1 is 1. 3 to the 0 is not 0. Be careful with that. It is 1. 1 over 1 is 1. Who can shout the second term? -2 over 3. How about the third term? Can you guess? What did you say? 1 over 3. Let's check. Dot, dot, dot. -1 to the n plus 1 over 3 to the n, dot, 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 close. So we have, I would rewrite 1 over 3. It is a very smart answer, so I would do like this. 1 over 3. But sometimes we ask not to simplify on purpose, not just because it's a first class. In general, actually, especially in data science, we want to see the pattern. So how did you get to 1 over 3? What was the pattern? How did you calculate 1 over 3 in the first place?
-1 to the 2 is 1, times 2 plus 1 is 3, so the numerator is 3.
3.
Denominator is 3 squared.
Yes, exactly. So it's going to be 3 over 3 squared. Thank you. 3 over 3 squared. Now, it's interesting to see if you can see the pattern. And that's why people who do puzzles might enjoy this chapter, because I see several patterns. What's the first visual pattern you see? Positive and negative. So the signs keep changing. That's called alternative sequence because it alternates the sign. It's positive, then negative. It's positive, then negative. And then we can actually claim we know when it's going to be positive and when it's going to be negative. When n, let me see. I will say when n is even, and it means the even term. So zero's term will kind of be just even. Second term, fourth term. Then a sub n term is positive. And then when n is odd, that's the first term, third term, and so on, then it is negative. That's called alternating sequence. Alternating sequence. Sequence usually S-E-Q. Alternating sequence. In the other pattern, I can see the numerator is 1, 2, 3, 4, 5, because it's n plus 1, n starts from 0. Changing the sign, but by absolute value, it's just actually counted. 1, 2, 3, 4, 5 is a numerator. Denominator is 3 to the n, so it's 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3. So it's going to be 1, 3, 3 squared, 3 cubed, 3, 4, 3, 5. Make sense? And then the result is a division of those two results. So that is the idea. Ask me, what do you think about this? Can you write it down at home by yourself? You should practice this new notation, because soon we're going to add, literally on Friday, we're going to add the sum to all of this. So you practice basic first, and then we're going to learn how to add this stuff together, because the sum will indicate pluses everywhere between. So we're going to have this on Friday. Before I move to Friday class, let me show you one more example and see who's going to understand that. Third one, C. Let me put in black, C. The example C is, let's reverse the order and find the nth term. Find the nth term. And this is harder than what we did before, because this is when you actually have to figure out, you have to have imagination. 1/2, 1/4, 1/6, 1/8, comma, dot, 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 can be written as what? You see, I don't use braces this time, because it's also a decent notation. It's still a list of numbers. They have a pattern. Do you see what the pattern is? How would you describe it with using n? I can see, thank you, but let me then wait next time for someone else also to help, because I know you're right. We could be using your answers to check. So I can see that the tops are always ones. That's the easy one. The top is fixed, it's 1. The bottom is not easy. The bottom is changing. So kind of I can see, okay, it's probably n squared, it's 2 and then 4, but then 6 messes it up. If it's just 8, next one, probably it's n kind of some power. So it's not 2 to the n, it's not n squared, blah, blah, blah. So then you think, okay, let's choose the first term. The first term, for example, can be 1. And for example means you actually choose which one gonna work. If n is 1, how would I write down the denominator? What do you think? The denominator, if we're choosing n to start from 1, 2n goes to infinity. So that was very fast, but I do know it is not obvious. And let's check. N is 1. The first term is 1 over 2 times n. That's 1/2. N is 2. 1 over 2 times 2, that's 1/4. N is 3. 1 over 2 times 3, that's 1/6, and so on. So I can see the denominators are all even. That helps me to figure out that I need to multiply by 2. And then I see there's no jumps, there's no gaps. So just n should be fine. Last one. 1, 1, 2, 3, 5, 8, 13, 21. Dot, dot, dot. That's an infinite sequence. Who knows? That's a good question. That's a very good guess. So I have a guess here that you add 2 previous together to get a third one. Do we have a name for that? Yes?
Like n plus n minus 1.
Ooh, let me write it down. What did you say?
N plus n minus 1.
Plus n minus 1. So we have the next one, starting from the third one, probably. Oh, I see what you're doing. The next one, adding with the previous one. Something like this. Very smart. Do we have the name for this? And I will check the answer for you. Yes? What did you want to say? Fibonacci sequence. Yes, good job, people. That's a famous one. You can check the Wikipedia. Let's write it down. It's and it stopped writing. Fibonacci sequence. Fibonacci sequence doesn't have an obvious notation for the terms. So it's a little bit not n plus n minus 1. And I will show you why. Fibonacci double C sequence, SEQ, a famous sequence. So indeed, I'm adding 2 terms, it gives me the third. I'm adding 2 terms, it gives me the third, and so on. So to recognize this pattern, the notation is this. We're first going to define 2 terms. The first 2 terms came up out of nowhere. They could be anything, but it's 1 and 1. So we're going to write down f sub 1 is 1. F is not a function, it's called f because of Fibonacci. So to respect his name, it's called 1. F sub 2 is also 1. So it's the second term, sub 2. And then f sub 3 will be what? No, not a number. F sub 1 plus f sub 2. And now you're correct. It is 2. I just wanted to have like one more note before what you said. So to write it down in general, that's just an example. We're going to do exactly what you mentioned. F sub n is the sum of the previous one plus the previous one. Or the way you mention it also will work. Is n and then n minus 1, or n and n plus 2. But then you have to fix this first term. So you can always do it as n plus 3 if you want, and so on. N, in this case, starts from 3. This is the nth term definition for the Fibonacci sequence. So there is an anecdote about this. The restaurant decided to announce famous Fibonacci soup. People got super excited, they went there and they ordered Fibonacci soup. And a soup was delivered and they asked, why did you guys name it first Fibonacci soup? And they said, oh, because we take the yesterday's soup and the day before yesterday's soup, merge it together and give you this one. Now you know the joke. Now you know the joke. Good job, people. Try to stay awake. And I will see you next time.